Let's practice factoring cubic polynomials completely when we're given a factor. To hopefully bridge the gap between synthetic division and polynomial long division, I'm going to go ahead and use both methods so you can see how they're related to each other. For number 1, here's our original cubic polynomial of x cubed minus 10x squared plus 19x plus 30. And here's the linear factor that we're given. Let's start with synthetic division. So to begin, let's go ahead and look at our linear factor here of x minus 6. And you got to figure out what makes it go to 0. Now, x minus 6 is equal to 0, so x would have to be 6. 6 minus 6 is 0. So we need to know that number first. Then we go ahead and look at our polynomial and figure out all of our coefficients. So here we have x cubed, which means that we have a 1 as a coefficient there. Then we look at this negative 10x squared. So what's the coefficient? That's going to be a negative 10. Then looking at our positive 19x, we have a positive 19. That's going to be the coefficient. And then finally looking at this plus 30 here, we have a positive 30 for that constant term. Okay, so at this point we can go ahead and set up our synthetic division. So we're just going to go ahead and put the 6 over on the side because that's what made our factor become 0. And then we're going to go ahead and put it on the side here and then write our coefficients down of 1, negative 10, 19, and 30. Now to complete synthetic division, all we're going to do is always bring this first number down. This 1 is going to come straight down. Let's go ahead and put that down here as a 1. Then we're going to go ahead and multiply this 6 multiplied by that 1, and that's going to equal 6. Let's go ahead and write that 6 over here. Then we're just going to go ahead and add these two numbers here of negative 10 plus 6. That's going to equal negative 4. Go ahead and put that down below. Repeat the process here. 6 multiplied by negative 4, that's going to be negative 24. Put that underneath this positive 19. Then we're going to go ahead and add this 19 and negative 24. That's going to equal negative 5. Put that down here at the bottom. Then repeat again, 6 times negative 5. That's going to equal negative 30. And then finally, we're going to add one more time here. And 30 plus negative 30, that's going to equal 0. Okay, so that's actually the remainder here, which means that x minus 6 was a factor because it divides perfectly. At this point, it's really important to know what these numbers at the bottom really represent, this 1, negative 4, and 5. And really, they actually represent the coefficients of a trinomial, right? So that 1 is going to really represent 1x squared. So I'm going to go ahead and write x squared here. That minus 4 is going to represent negative 4x. And then that minus 5 is just going to represent a constant. So when we go ahead and look at this 1, that's really 1x squared. This minus 4, negative 4x, and minus 5 is negative 5. So the factors for x squared must be x and x, and then the factors of negative 5 that add to get to negative 4 are going to be negative 5 and positive 1. So if we multiply x and negative 5, that's negative 5x. X times 1 is positive 1x. Negative 5x plus 1x is negative 4x. So we know that this is going to factor into the quantity of x minus 5 times the quantity of x plus 1. So now that we factored this trinomial into these two linear binomials of this x minus 5 and x plus 1, we can really just take this x minus 5, x plus 1, and also combine that with this x minus 6 factor that we were given from the beginning. And if we multiply those all together, that should give us our original polynomial or cubic polynomial that we started with. The completely factored polynomial here is going to be f of x is equal to this quantity of x minus 6 that we were given in the beginning, and that's going to be multiplying by the two linear binomials that we came up with using our synthetic division of the quantity x minus 5 times the quantity here of x plus 1. Alright, so while we just went ahead and solved this using synthetic division, I'm going to go ahead and do it using polynomial long division so that hopefully you can see the similarities and differences between the two strategies. If you want to skip ahead, feel free to do so. If you want to stick around and see what's going on here, hopefully this might be helpful in some way. Okay, so I'm going to go ahead and put the x minus 6 on the outside where the divisor goes, then put this x cubed minus 10x squared plus 19x plus 30 on the inside as the dividend, and go ahead and complete some long division here. So we have to multiply something by x to get x cubed to begin here. I'm going to go with 1x squared, so I'm going to put just an x squared on top. If we distribute this x squared to this x and to this 6 here, what we're going to get is x cubed minus this 6x squared. And if we go ahead and give that a hug and then subtract, let's see what's going to happen here. So we should have some stuff cancel out. The x cubed and x cubed cancel out, and then the negative 10x squared minus negative 6x squared you're going to add there. So that's going to end up being, 4x squared here. So negative 4x squared. Now a couple key numbers to kind of keep track of already is this 1 over here, and notice that we have a 1 in front as well. You can also notice here that we had a 6 over here, and if we're taking away a negative 6, that's really where that positive 6 is coming from. And this negative 4 down here is really this negative 4 that's over here in the long division. Okay. Next here, we're going to go ahead and bring down this 19x, so we're going to go ahead and write plus 19x. And let's repeat the process here. I'm going to go ahead and put a minus 4x on top, okay? And let's take this negative 4x and multiply that by x and multiply that by negative 6. So if we do that, that's going to be negative 4x squared, and then that's going to be a plus 24x. Okay, let's go ahead and give that a hug and subtract. So if we go ahead and subtract these from each other, let's see what the remainder is going to be. The negative 4x squared minus negative 4x squared will cancel out. The 19x take away 24x should be negative 5x. Okay, cool. So let's just pause for a moment again. If you take a look at this negative 24 that's here, you can see that if we take away a positive 24, that's really a negative 24, right? And then also if you notice here, this negative 5 is really the same as this negative 5 over here. Okay, I think we can just go ahead and do one more step here, bring down this 30. So we bring down a 30, that's going to be a plus 30. And let's see, I think we're going to just put a minus 5 up here, right? Minus 5, let's go ahead and distribute that to this x and to this negative 6. If we do that, that's going to be negative 5x and then plus 30. And again, like everything is a factor here in this this worksheet, so or in this set of practice problems, so there should be no remainder. Obviously, there can be sometimes in many cases, but in this instance, we're not practicing those right now. Okay, so the remainder is 0, and so you can notice here that we had this x minus 6 that we were dividing by. Okay, and then we're ending up with this trinomial, which is what we really had from these coefficients here. We took that trinomial and we factored it, and then we got these two binomials. So I'm not going to factor that part again, but hopefully you can see where the similarities and differences are here. All right, here is number 2. For number 2, here is our linear factor. And here is our cubic polynomial that we are working with. First, let's notice what makes this linear factor become 0, and that's going to be negative 4, since negative 4 plus 4 is equal to 0. Then looking at each of these terms, let's see what each of their coefficients are, or their values are. So first we're going to have a positive 1 here, then a positive 6, then a positive 5, and a negative 12. So those are the numbers that we are going to go ahead and use. So negative 4 was our 0, or the number that makes our linear factor become 0. So let's put that negative 4 off to the side, and then let's put our coefficients of 1, 6, 5, and negative 12, run those across, and let's set up our synthetic division here. Okay. All right, let's bring this 1 straight down to begin. Then negative 4 times 1 is going to be negative 4. 6 plus negative 4 is going to be positive 2. Negative 4 times 2 is negative 8. 5 plus negative 8 is negative 3, and then negative 4 times negative 3 is positive 12, and then negative 12 plus 12 is equal to 0. So you can see, because we have a remainder of 0 here, that this x plus 4 was indeed a factor, right? It goes in perfectly, okay? Now let's go ahead and see what we can find out with these coefficients over here. Remember that each of these stands for a coefficient for a quadratic. If there's 3 things here, or 3 values, that means it's going to be a trinomial. And so that 1 is really representing 1x squared. That positive 2 is really representing 2x. And that minus 3 really represents a constant of 3. Okay, so the last one's always a constant, and then you can move to the left and go up powers. Okay, so what makes x squared? That's going to be just x times x. And then what 2 factors of negative 3 also add to get the positive 2? Let's go with a negative 1 and a positive 3. Okay, just because negative 1 plus 3 is going to equal 2, and so that's going to be, if you multiply, it's negative 1x, positive 3x. That does work out here. Okay, so our binomials here are going to be the quantity of x minus 1 and the quantity of x plus 3. Okay, so we just, again, took these values over here at the bottom, and that helped us figure out these two linear binomials after we factored the trinomial here. Okay, so if we're going to go ahead and write our final factored form for our cubic polynomial, we know it's going to be f of x is equal to the quantity of, let's go ahead and use our linear factor they gave us, this x plus 4. And then what did we find out? Using that information, we were able to find out that we had x minus 1 as another factor and x plus 3 as a third factor. Here's what the polynomial long division would look like. Okay, so if we want to just take a look at some similarities of what's going on between the two methods here, just so we can kind of see the relationship, we can see this 1, and that's because we have an invisible 1 or a coefficient over here. We have this negative 4, which we're taking away this 4, right? We have a 2 at the bottom, which makes sense. We have a 2 right over here. We have a negative 8, which we are taking away 8, right? Same idea. Then we have a negative 3, which is right over here. We have a positive 12, which we are taking away a negative 12, which is where the positive 12 comes from. And we have a remainder of 0, which then checks out in that we were given in the beginning that x plus 4 was a factor, so there should be no remainder when we divide. Here's number 3. For number 3, this is going to be our linear factor, and this is going to be our cubic polynomial that we're working with. The 0 for our linear factor here is going to be positive 8, since 8 minus 8 is equal to 0. And then for figuring out our coefficients here, let's go ahead and see all these numbers. But it looks like we have a positive 1 to start. We have a negative 2, a negative 40, and then a negative 64. So those are going to be each of our coefficients or constants here. Okay, so let's go ahead and set up our synthetic division. All right, so let's throw our 0 of 8 on the side here. And then let's put our coefficients and constants, just run those across. So we have this 1, negative 2, negative 40, and negative 64. Okay. And again, when we're doing synthetic division, just keep in mind that for all these problems, we should get a remainder of 0 just because we're told that this x minus 8 is a factor, right? So let's just get right into it. Let's bring this 1 straight down. And then we have this 1 times 8 is going to be 8. And this negative 2 plus 8 is going to be 6. 8 times 6 is 48. Let's put that underneath the negative 40 and add these. Negative 40 plus 48 is positive 8. 8 times 8 is going to be 64. And then if we add negative 64 and 64, we get 0, which checks out that a remainder is 0. Now let's go ahead and make sure we understand what this 1, 6, and 8 really represent. The 8 is a constant, 6 is 6x, 1 is 1x squared. So this translates into just being x squared plus 6x and then plus 8, okay? And that's a trinomial. We should try to factor it. So the only thing that multiplies to x squared is going to be x times x. And then for 8, it could be, I think, 4 and 2, right? Positive 4, positive 2. So if we go ahead and multiply x times 4, that's going to be 4x. X times 2 is 2x. 2x plus 4x does equal 6x. So going ahead and writing these out, we're going to have the quantity of x plus 4 times the quantity of x plus 2. Right? That should multiply to get that trinomial. And so we can go ahead and write our factored form for this cubic polynomial and say f of x is equal to, take that linear factor they gave us, which was this x minus 8, and multiply it by the two linear factors we just found, which is going to be this quantity of x plus 4 times a quantity of x plus 2. This would be our completely factored form. Now I'm going to go ahead and show the long division for this. If you want to pause and try it with me or just skip ahead, feel free to do so. So just noticing some quick similarities, we have this 1, which we have a 1 in front here. We have this 8, which is really representing this taking away of a negative 8, which is adding 8. We have a positive 6, which we can see a positive 6 here. A positive 48, where we're taking away a negative 48, which is a positive 48. We have an 8 down here, which is another 8 as well. And we have a positive 64, which taking away a negative 64 does result in a remainder of 0, which, look at that, it checks out with a 0 down here as well. So we get this trinomial of x squared plus 6x plus 8, which is what we got over here as well. Here's number 4. Here's the linear factor that we're given, and here's the cubic polynomial that we are working with. The 0 for this linear factor is going to be negative 10, since negative 10 plus 10 is equal to 0. And then we should have 4 different values from these 4 terms. Our first one's going to be a 1, then we have an 18, then a 95, and then 150. All right, let's go ahead and put our negative 10 on the side here. That's the 0 for our factor. And then let's go ahead and put our other values of 1, 18, 95, and 150 over across. Let's go ahead and set up our synthetic division here. Okay, so go ahead and bring down this 1 just like we've been doing. So that's going to be a 1. Negative 10 times 1 is negative 10. 18 plus negative 10 is going to be positive 8. Negative 10 times 8 is going to be negative 80. And then 95 plus negative 80, or 95 minus 80, is going to equal 15. And then negative 10 times 15 is going to be negative 150. And then if you add 150 plus negative 150, that should equal 0, which then checks out here because that's what we were supposed to get. Now, taking a look at these 3 values over here, they should tell us our coefficients for our trinomial. So we're going to get 1x squared plus 8x and then plus 15. Okay, now let's see if this is factorable. I think it is. So x times x does get you x squared. And then let's see, I think 5 and 3, that's going to get you 15, but also 5 plus 3 gets you 8. So that's going to be 5x and 3x. 5x plus 3x does equal 8x. So we can factor this into the 2 binomials of the quantity of x plus 5 times the quantity of x plus 3. Okay, so we have everything we need now to write our factored form. So we can say that f of x is equal to the factor we were given of the quantity of x plus 10. And then we found the other 2, which was really this x plus 5 multiplied by the x plus 3. This would be the complete factored form for the cubic polynomial that we started with. Now for the synthetic division. So again, hopefully it makes sense here that if we have something with degree 1 or linear, and we multiply that by something with degree 2, which is quadratic, then we get something that is degree 3, which is going to be cubic over here, right? And it looks like in this case, as we've done in the other practice problems, that this quadratic was then factorable into two linear binomials. So when we have a linear times a linear times a linear, or degree 1 times degree 1 times degree 1, we do end up with a degree 3 that we started with. Here's number 5. For number 5, here is our linear factor, and here is our cubic polynomial. What makes this linear factor become 0 is going to be -9, so let's go ahead and put that down, and let's take a look and see what are all of our values that we're going to need here. So we're going to take a 1 from this leading coefficient, and then a 2, and then a -51, and then finally a 108. Okay. So we have everything we need to do synthetic division, so we can put this -9 on the side. And then let's go ahead and put our other values running across. So we have 1, 2, -51, and then 108. And so if we go ahead and set this up, let's see what we can do here. So this 1 is going to come straight down, and then we have -9 times 1, which is going to be -9. We have a 2 plus -9, or 2 minus 9, that's going to be -7. And then -9 times -7 is +63. We have -51 plus 63, or 63 minus 51, that's going to be +12. And then -9 times 12 is -108. And these are opposites, so they add to get 0. So that makes sense because that's what we wanted our remainder to be. Now, making sure we understand what these three numbers represent, they should help us create a polynomial, or a trinomial rather, and it's going to be quadratic. So we're going to have x squared minus 7x plus 12. Okay, cool. So let's go ahead and see if we can factor this. So for x squared, that has to be x and x. And then for the factors of 12 that add to get to -7, that's got to be a -4 and a -3. All right, just because c is positive but b is negative, we need two negative values here. So x times -4 is -4x. X times -3 is going to be -3x. So -4x, -3x makes -7x. So we now can, factor this into this quantity of x minus 4 and x minus 3. That would be the factored form for that trinomial. And then so we can write our factored form for the entire cubic polynomial that we started with is f of x is equal to the x plus 9. They gave that one to us, right? Later on, by the way, you're going to have to, factor these, and when they don't give you one, so that's a whole nother lesson, another practice video, hopefully. And so we can go ahead and write these three down, but it's kind of nice that we're given at least one factor, at least for these set of practice problems. This is now completely factored. Now here's the long division if you are interested. So hopefully here you can see that the long division does match our synthetic division, and if you want to take a look at it, feel free to pause and look at it a little bit longer just to make sure everything makes sense. Otherwise, let's move on to number 6. For number 6, here is our linear factor here, and so from there right away I'm just going to say that this is going to be a -2 for the 0 that we're going to use. And then looking at this polynomial that they are giving us here, we can notice here that looking at the 4 different terms, we need 4 different values here. So it looks like we have 3 positives and a negative. We have a 1, a -9, a +8, and then a +60. Okay, so let's go ahead and set up our synthetic division using all of these numbers. So -2 is going to go off on the side here, and we can put this 1, -9, +8, and 60. And let's go ahead and start our synthetic division. This 1 can come straight down, and then multiply this -2 times 1 is going to be -2. Then adding -9 plus -2, that should be -11. And then multiplying this -2 times -11, that's going to be a +22. 8 plus 22 is going to be 30. And then -2 times 30 is going to be -60. And then 60 plus -60, or 60 minus 60, those are opposites. We should get 0. Now, just looking at these 3 numbers, they should tell us our coefficients for our quadratic here. So this is going to be 1x squared minus 11x and then plus 30. And this should be factorable. We have an x and an x here. And then for 30, I'm thinking of -5 and -6, just because we need 2 negatives to get a positive, and we need 2 negatives because we have -11x in the middle. Okay, so if we multiply across here, we get -5x, -6x. They combine to get -11x. And so our 2 factors here are going to be the quantity of x minus 5 times the quantity here of x minus 6. So we can go ahead now write our factored form for the cubic polynomial we started with. F of x is equal to this quantity of x plus 2. That's the one we were given. And then the 2 we found were this x minus 5 and this x minus 6. So this would be a completely factored form. And here is going to be the long division if you're interested. And let's give that a go to see if everything matches and checks out. So here you can see once again that this does work out, and this quadratic that we got as our quotient here, that you can see that these coefficients do line up nicely. Okay, let's check out number 7. For number 7, we have this linear factor of x minus 1. So from that, we know that we are going to have a 1 for our 0. We're going to go ahead and use that. And notice here that we have a cubic polynomial. This time it's a little bit different, right? Just notice these subtle changes here. But we still have 4 terms, right? That's not the difference. But there is a slight difference in that our first coefficient, our leading coefficient, is a 2, right? So I know it's super exciting. First time we have a different leading coefficient here. If you're getting used to it, of a 1, it's not always a 1, just so you know. Let's put this 1 on the side for our root, or our 0 here. That's 1, and then we can go ahead and put this 2, and then -15, 34, and then -21, right? Those are all going to go across here. And then let's go ahead and get going with our synthetic division. So the only difference here is this 2 is going to come down, so don't overthink if it's a different number. 1 times 2 is going to be 2, and then -15 plus 2, -13. 1 times -13 is -13. 34 take away 13 is going to be 21. And then 1 times 21 is 21, and then these opposites make 0, right? So this does work out, and we have no remainder. Now let's go ahead and take these three numbers and make sure we know what to do with them. They should make a quadratic polynomial. So we're going to have this trinomial of 2x squared minus 13x plus 21. Okay, so factoring quadratics, again, really important. It's a little bit trickier here because a isn't equal to 1, but a is prime, so it has to be 2x and 1x, right? It can't be anything else. And then for 21, it's got to be a negative and negative because we have a negative 13. I'm going to start with a 7 and a 3. Okay, a negative 7 and a negative 3. If it's not that, it's got to be 21 and 1 here. So if we go, let's go diagonal here. 2x times negative 3, it's negative 6x. This is going to be negative 7x. So that's going to be a total of negative 13x. So those are our outers and our inners. And so let's see here. This 2x is going to pair with the minus 7. Right, because the 2x has to multiply by the negative 3, so we're going to go ahead and put the 1x and then minus 3 for our other binomial. Okay, so again, those lines going across represent the outers and the inners, so make sure when a is not equal to 1, you feel like you know what to do when you're factoring. A little bit more work. Okay, all right, so all the hard work is done. We just have to write the factored form, so f of x is going to be the quantity of this x minus 1 multiplied by this 2x minus 7 and x minus 3. Here's your final factored form, and here is the polynomial long division. All right, cool. So you can see here that this quadratic up at the top, our quotient, does match what we had over here, which really can be represented by these three values over here as well. Okay, here is one final practice problem. This x minus 5 is going to represent our linear factor that they're giving us, so our 0 for that is going to be this positive 5. And then looking at this cubic polynomial over here, we have 4 terms, 1, 2, 3, and 4. Lots of negatives here. So we have a positive 3, but we have a negative 2, a negative 61, and a negative 20. Okay, so let's go ahead and use those 4 values with our 0 or a root of 5. So put 5 on the side here. And then let's take our numbers of 3, negative 2, negative 61, and negative 20. All right, so let's set this up here, and let's bring down this 3. And so we have a 3, and then 5 times 3 is 15. Negative 2 plus 15 is going to be 13. 5 times 13 is going to be a positive 65. Negative 61 plus 65, that should just be positive 4. And then 5 times 4 is going to be positive 20. Negative 20 plus 20 is going to equal 0. And so that works out. Pretty happy about that. And so if we go ahead and take these 3 values over here, that should create our trinomial that we can hopefully factor, which is going to be 3x squared plus 13x plus 4. Okay, so a doesn't equal 1, which is definitely a little bit more work, but a is prime, so we know it has to be a 3x and a 1x. And then 4, let's see, it could be 4 and 1, or it could be 2 and 2. To get this 13 in the middle, though, I'm thinking it's going to be 4 and 1, just because if we multiply 4 times 3, that'll get you this 12x, right? And then we have 1x, so 12x and 1x would get you 13x. So that's my thinking there. And then so if we pair these up, remember this 3x and the 4 have to kind of multiply together, right? So I'll write it this way. I didn't write it really in this order last time, but maybe this helps make sense. These are outers. Again, the lines help pair up the outers. And then let's see, the inners are going to be x and then plus 1. Okay, so just make sure whatever you're pairing up with the lines, that's going to be your outers and inners, because that's what's actually going to multiply together. Okay, so our factored form here is going to be f of x is equal to, we have this x minus 5. Go ahead and write x minus 5. And then we found out our other two factors here are going to be 3x plus 1 and then x plus 4. And just one final time, here is the polynomial long division, just to wrap everything together. Hopefully you can see all the connections. And so one final time here, we can see that this trinomial that we get for our quotient, that their coefficients really match the 3, 13, and 4 here. And then we went ahead and factored those earlier to then get these linear binomials. So everything does check out here. If you look closely, each of the 8 practice problems in this video started off as cubic polynomials, and when we finished writing their factored form, or fully factored form in this case, we had 3 linear binomials, so they're all degree 1. So 3 factors that are degree 1 when they're multiplied together should get you something that is degree 3 to begin with. Okay, so if you found this video helpful, please consider giving it a thumbs up, and as always, keep up the great work that you're already doing, and I hope to see you in the next one.